Hey everybody, Lars here. It is time for the beginning of Big Bad Unit 5, but Unit 5 isn't really that bad. Uh, it goes over object orientation, which is kind of a different way to write our programs, as you're going to see as you go through the chapters and you go through the slides. Just think of it as the melding, and you're going to get this when we go inside the video, melding your data with what you can do with your data. So the functions that you can run on your data are put together with your data, and you're going to see what I'm talking about as we go through it. Again, for time reasons, I'm not around tonight. I'm shooting this on Monday, the 3rd. The Mets won 6-0. So hope springs eternal for the New York Metropolitans. And tonight is the NCAA championship game. Gonzaga, UNC, insanity at the college basketball level must be witnessed. So what I'm going to do is I'm going to go revitalize a video from 3 months ago where I go over a class in object orientation. I think I do my bank account class. So we're going to go over that. And then stay tuned because at the end I'm going to get back on like I am now, live and in person, and we'll do some announcements. Not a lot of announcements to do. But I don't want to front end it and just end the video. So we'll start up the video now, go through it. I think it's going to make a lot of sense if you read the slides and we're kind of fuzzy, and you read the book and we're kind of fuzzy. Once you see it in action and you see me do the bank account class and you see everything working, I think then you'll be okay. And by the second video, we're going to do an animal class, and then we're going to, set up inheritance off of the animal class and create a dog class and a cat class. And I haven't decided yet, but I may do that one in person just to go through some different stuff that I'm seeing as we go through things. All right? All right. So without further ado, here is the lecture that I gave 3 months ago on object orientation in classes. And stay tuned at the end because I'll do some announcements then. All right? All right. See you soon. Bye. I figured we'd start off by talking a little bit about what object orientation is. Object orientation is a different way of thinking about writing our computer programs. As I said in the past, and I'll bring up some stuff with the slides in a minute, we've been using a style of programming called imperative programming, where it's almost like we treat solving our problem like we do using a recipe if we were cooks. We collect all our data just like we would collect ingredients, and then we perform a bunch of actions on that data until we get to the solution, just like we would collect eggs and flour and milk, and then we would do certain things to it, and then at the end we'd get a cake, our solution. That was the way computer programming was approached for a very long time. There's other ways of looking at programming. There's functional, there's aspect-oriented, there's different ways to do it. But in the 80s, a language came out called Smalltalk, which started using object-oriented techniques. And what it means to program in an object-oriented fashion is that when we create our programs, we use data, obviously. And so far, we've seen things like integers and floating point numbers and strings. And then we even get a little more complex by creating lists and creating files with our strings and things along those lines. But people started to think, what if we went even a step higher and began to model our data based on real objects that they're representing? Like if you had a bicycle, well, why shouldn't I have a data type called bicycle? And that bicycle could go forward. That bicycle would have 2 wheels. That bicycle would have a color. And you would break it down on the things that real life objects actually have. Their attributes, color, size, name, and their behaviors, what they actually do. And what object-oriented programming does is let us create a data type that actually represents this real world item so that we could have its attributes described and then list its behaviors. But in our case, because we're programmers, our attributes are going to be data items. So basically, it's a sophisticated data type where we collect all of the data about the object or item in one place, and then we have our methods. Now, as I said in the slides, methods are nothing but functions. They're functions that are related to that particular data type. So you have all of the data that you would use for a particular item, and then you would have all the different things you could do with it, its behaviors, and we implement this via methods. Let's take a look. I think I have the slides queued up. Do I? Don't I? Wouldn't I? Yeah. What is object orientation? I talk about how it's a grocery list, and then I start talking about objects and how we create a more sophisticated data type to actually represent these items. And what I always compare classes to is blueprints, because when you create a class, that's what you're doing. You're creating a blueprint that you're going to use later to create an actual object with. And when we create that actual object in programming, it's called instantiation, because you're getting a real honest-to-goodness instant of that class that you can then use and give real data to and run the methods on that data. And that we call these blueprints classes. And in your slides, I go through some things about classes, how you can have the class, which is the raw blueprint, very general, but then you can give it specific data items. And as you'll see later when we talk about inheritance, we can even give it specific behaviors. And then we could use our data. This sounds like highfalutin, high-level theory stuff, but when you see it in action, I think it's going to make sense to you. So I go about describing that, and then, as I believe Zell does in the text, he uses a die and codes up a class for dice. Because I want you to see a couple different examples and a couple different ways of doing this, am not just going to trace through the die code. I think I'm going to create a brand new class for us right here live and in person, and I haven't decided what I'm going to do yet, so let's see what I can come up with on the fly. Just as a final thought before we start coding, just think of classes as blueprints, and what objects are is a high-level data type where we have our data and our functions or methods that we run on that data together. They're associated with each other. Think about it, because truth be told, you've been using objects all along. A list is just an object. When you say dot replace or dot split, you're running a method on that object that you have, and that object happens to be a list. That's the way I've always thought about it, as just a higher level data type. If you ever had any experience with the language C, there's a keyword called struct, where you could create your own high level data types and group your data together so that it makes more sense as far as representing the real world. Because that's, at the end of the day, that's what we do. We represent real world things, we manipulate our data using our programming tools, and then we come to an answer. And because if we've done that representation properly, we can take that solution and relate it to the real world and use that solution in real world problem solving. That's the name of the game. That's basically what we're doing when we do computer programming. The problem, not really a problem, but the fact of the matter was, I, went to school in the 80s. Let's just put it this way. When I was born, the Beatles were still together. So they weren't exactly teaching object-oriented programming at university when I went. So a lot of people my age and older had to go out and teach ourselves object orientation later when it became popular with the language C++, and definitely when Java came along. So a lot of people who haven't had formal university training with object orientation think about it a certain way, and I believe they probably think about it as it relates to the structs in C, grouping together data and making a very high-level data type that you can then use in your programs. Enough of me blabbing. Let's just do it. Let's get a new file. Okay, what am I going to model? First thing I'll do is I'll leave my comment. Demo of a class for. Okay. shouldn't be too hard. Let's say I want to write a class so that I can create a savings account that is used by a bank and can be used for banking programs. So let's say a savings account. Okay, what's the first thing I want to do? I want to type the keyword class, and I will call my class S account. I'll call it savings. And I will give it a colon, boom, and there we go. I've now told Python I'm going to create a class, and I'm going to call it savings. Now, very importantly, when we create these blueprints, we create them so that we can use them to create objects later. And when we create these objects, there's usually some things that we want done. If you're creating, let's say in my case, I'm creating a savings account. I'm going to want to give it an initial balance. So I'm going to want to give it a balance. I'm going to want that data item set. I may want to do some other things, maybe set, if I were doing an animal, I'd want to set its color, how, old it was, blah, blah, blah. So there's a method or a function that always runs when we create the object. And this method is called a constructor. Whenever you hear the term constructor, it's just the function that's run every time the object is created. That's all. Not that complicated. Now, in Python, a constructor has a particular name. You saw it in the slides. Underscore, underscore, we call them dunders or double underscores. They have a special meaning in Python. So don't use them in your variable names because they have a special meaning. As we learn more about the inner workings of Python, you'll learn more about dunders. But in this case, we call it init, which is short for initialize. So dunder, init, dunder is the name of constructors in Python. Later on, in a couple of videos down the road, we're going to learn about overriding functions. We're actually doing that here. And it's a complicated story that we're going to get to at another time. So I want to set an argument list because the rules for constructors, a constructor is just a method is just a function. It's the same as when we were creating functions. So this next part is a little nuanced. I type self. What does self mean? Self is a special term in Python that says refer to myself. So later when we create the object, and that object is going to be tied to a variable name, and it's going to have a space in memory, and it's going to be an actual instantiated thing, we always want to pass that in when we call these things. And Python will do that automatically for us if inside the class we just refer to self. You'll see later when we call these methods, you don't have to put self in there. It's done automatically. What else do I want to do? Let's say amount. I'm going to put in how much I want for an amount. And then what do I want to do in here? I'm just going to say print. You have created a savings account. And then I'm going to refer to what's called an instance data, or a piece of data that is only going to refer to my object after I create it. So I want to call it self dot, and I'll call it balance equals amount. You know what I'm going to do too? Just to be a good doobie, I'm going to make it float amount. So I get floating point, which is what I should be using for numbers already. All right. So that looks good to me. Let's do this first, because I think it would behoove me to remember def when I do my definition of the method, because they're just like functions. Okay, I've written my constructor. So when I create this object, I'm going to hand it a dollar amount so that it can create this, and it's maintaining a instance variable called balance that's going to hold the value of my amount. So what else would I do with a savings account? Now is the time where I need to define the behaviors or the things we're going to do with our object. I know one thing. I would definitely do. I would definitely make a deposit. And I think this could be easy. Print. You have deposited. Yeah, how's that for some spelling? Deposited, comma, amounts. Good enough. And then I would change self.balance. This is a new wrinkle. I think I showed it in some of the slides or something I did last week. But if you just put plus equal, it's the same as doing self plus self.balance equals self.balance plus something. It means I'm not reassigning that. I want to add what's on the right to the thing that is on the left. So it's not necessarily an increment. We don't have increments if you guys are dying to use plus plus or minus minus for decrement. But it almost acts like we've always done with our counters and our accumulators, you know? Count equals count plus 1 or amount equals amount plus whatever. It saves a little bit of typing and lets you do it quickly. And in my case, I want to do something. I don't think it would matter because it would do it anyway, but I'm going to do it. Float.amount. Okay, good job. So I've now written a method called deposit that's going to allow me to deposit money into my account. I probably should have done this beforehand. I'll actually come up here and put it up here so I can define it here. When we create classes, we create the name, we create the constructor, we set our data items to what we want them to be, and then there's usually another convention in which we create methods that are called getters and setters. Now, in our situation, we have a savings account. So I have one data item in here, the balance. I don't really need a setter because to set that balance, I'm never really going to reset that balance. I'm going to alter it by doing deposits. And as you'll see in a minute, I'll write a method called withdrawal. But if I want to see what my balance is, I could use a getter. And a getter is basically just something that returns that particular data item. So classically, getters would be get and then the name of the data item. I just put myself because that's all I need. All of the methods we create are going to have self in their argument list coming first. And all I would do here is return self.balance. And there you go. So when you run get balance, it's just going to return the value of the balance so that you can see what the balance is. And you'll see how we run all these in a second. I will instantiate this class and we will use it in a program right underneath this class declaration, as a matter of fact. So the last thing I want to do is I want to define a method called withdrawal. And I'm going to want to have an amount for that too. Nice. Now, unlike deposit, where I'm assuming I have a positive amount, I'm not going to error check that. I'll always put in a positive. But when you do a withdrawal, you do want to make sure that whatever you're withdrawing is less than or equal to your balance. Otherwise, you don't have the funds to do what you want to do. So what I'm going to first ask here is I'm going to say if self.balance is less than or equal to amount, then I know I'm good. So then I'm going to print you have withdrawn amount. And then I'm going to make self.balance. I'm going to remove the amount value. So remove float amount. Now the else case here is if I do not have the balance to cover my withdrawal amount. So at that point I will just print you do not have 1F, 2F, sufficient funds. Okay. Does that look okay to me? I'm sure something's hinky, but we'll find out about it later. All right. This is basically our simple class. I decided to create a higher level data type or a class or a blueprint for a savings account. When I first create this object, I will run the constructor method, or in this case, dunder init dunder, and that will take an amount to create my account. You know, whenever you go open a savings account, you always have, here's $100, here's $200, whatever. So when I do that, it'll say I have created it, and it'll set this instance variable, self.balance, equal to the amount that was given when I created the object. I'm making it a float because it's money. All right, and then I define 3 methods. One is called getBalance, just returns the balance, that's all. One is a deposit. Whatever amount I give it, it's going to say I've deposited that amount, and it's going to add it to the balance variable. Then I have a method called withdrawal, in which case I give it the amount, and that's the amount I'm going to take out of the bank or take away from my balance. And as you can see, if I have the funds to do it, I say I've withdrawn this amount, and then I decrement, or I take away that amount from the balance. Now, if I don't have the amount, if amount is greater than balance, then I say I don't have sufficient funds and nothing occurs, okay? So let's see if the programming gods are with me as I use this. Now, just like we've done with other data items and other lists and other things like that, I am going to say, I will call it Lars account, and I will make it equal to savings, the name of the class, and I'll give myself $200. I'm daddy $4. All right, so now I've created an object. It's a real instantiated object that acts just the way we defined it in the blueprint or class, and I can use all of those methods on it. The first thing I'm going to do is I'm going to say A equals getBalance. You see I have 2 closed parens. I don't give it self because Python knows to do that automatically. And then I'm going to print A. So if I'm not mistaken, let me save this first. I will go to PMDS. I will go to Unit 5. I will go to Code. And I will call this savings.py. And when I run it, we'll see what happens. Uh-oh, dun, 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 dun. A equals getBalance, and then getBalance is not defined. The name getBalance is not defined. Def getBalance. Did I misspell something? I have to say Lars account dot getBalance. And say, look at that. Ain't you nice? It will actually tell me all the different methods I can run on my particular object. But in this case, I want to give the object and then dot and then the method I want to run on it. So it's Lars account dot getBalance. It's not just getBalance out there in space. Let's hope that was it. And it was. It says you have created a savings account. Now, why did it say that? Because when I created the object, the constructor was run. So when the constructor was run, it printed, you have created a savings account. And then it took the instance variable, self.balance, and made it equal to 200. That's all. It didn't print it. Now down here, I say let A equal Lars account.getBalance. GetBalance is a fruitful function. It's going to return a value, so I want to set it to a variable so I can keep that value. So when I ran getBalance, it returned self.balance, which was set up here. So A is equal to 200, and then I just print it out like that. So I've created my variable. I have it in there, and now I can start doing things with it. So I can give myself some more money. Isn't this nice, this little world we have here where I can just give myself money anytime I want? I could say deposit $300 for me, please. And then after I do that, I'm going to want to check the balance. So I'm going to just cheat a little and grab that section right over there and do it again. So let's see what we get. All right, I've created a savings account, 200. Then I deposit 300, and now I have a balance of 500. That's correct. Let's trace through the code and see what happened. I created my savings account. I ran my constructor, and it set the instance variable to 200. Then I ran larsaccount.getBalance, and it returned the balance to A, and I printed it. Then I said, okay, let's use the deposit method and give me $300. So I went up here to deposit, where self is the object itself, and then amount is 300. I print, you have deposited 300 right there. And then I increase the balance by that number. So the balance in that operation right there went from 200 to 500, but I don't print it there. What I did was I went and got my balance again by using the get balance method. I set it equal to A, and I printed A, and that's why I got the 500. Okay? One last test of this wonderful little savings account. Let's say Lars, I keep wanting to put a dot there, and I don't know why. Lars account withdrawal. And I'm going to try to withdraw $600. I wish life were this simple. Now, I'm not even going to print it out because I think I know what's going to happen. Let's find out. Ta-da! It says you have withdrawn 600. What happened? I have 500. Let's see. Withdrawal 600. If self balance is less than or equal to amount. I want balance to be greater than or equal to amount for me to do that. And then if it's not the other way around, have that corrected things? Yes, it has. You have created a savings account, 200. You've deposited 300. We're now 500. Now, Lars withdraw 600. I run the withdrawal method. Self is the object itself, passed in automatically. Amount is 600. If self balance 500 is greater than or equal to 600, true or false? It's false. So I forget about my withdrawal operation because I can't do it, and I print you do not have sufficient funds. Then that is what happens. You do not have sufficient funds. Now, my balance should be the same because nothing should have happened. Let's go see that that is the case. And it is. I'm still at 500 because it wouldn't let me do the operation. But let's do this. Copy. I know I didn't grab that one. And now I'm going to try it with 400. Okay? So I'm going to try to withdraw 600 from a $500 account. It's going to tell me to go pound salt, and then I'm going to start all over again. I say, oh, yeah, you're right. I only had 500. Let me try to get just 400 this time. And this time when I run it, you can say you've created a savings account. You deposited 300. That makes it 500. My 600 didn't work, and I still have 500. But now I withdraw 400, and I have 100 left as a balance. Because what happened? I came up here, and I went to withdrawal, object itself, which is passed in, amount 400. If 500 greater than or equal to 400, that's true. So then I print, you have withdrawn the amount, in this case 400, and then self.balance, I remove that amount. And the last thing I do here is I should start doing this because it's the easy thing to do. And you guys know variables by now. So we can make life easier and just start doing that and put it inside the print statement so we don't have to set a variable, because you don't have to set a variable all the time. All I want is the item, and as long as I'm doing something with it, then the fruitful function is not in vain. It returns the value, but I am using it because I'm printing it, even if I'm not setting it to a variable. Okay, so that's how withdrawal worked. So as you can see, if I come down here and I say Lars account, it tells me the location of my object so that I have an object. Let's see, do I still have A? Yep, I still have A, the old balance, before it was reset. See, A is not 100 now because I got rid of that. The last time A existed was right there. Okay? This is the basics of creating a class. Let it sink in. Read the slides. Read the Zell chapter. Watch this video again. It's not hard. It's just taking everything that we've been doing separately and on our own and grouping it together and doing things in a more organized fashion. That's really all it is. We've created a blueprint where in this constructor, we're going to do things when we create this object, and then we're going to set our data. So in here, all your data is going to be set. Think of the constructor as the place where you set your data. And then you're just going to create a list of functions, although in object orientation we call them methods, that you can use to work on your data. That's all it is. But imagine if you had to write this particular program in the old way. You could do it, and you could do it pretty easily, but you'd be making a lot of assumptions and doing things. You would set up a variable and you would say, okay, I know that's the balance. Now it wouldn't be set in an object called savings account, but you'd know that was the balance. And then you'd write a function called withdrawal and a function called deposit, and you would alter the variables that way. This kind of makes it more organized. With this object, you have everything in one place, and it's a more logical representation of the real world situation you're trying to mimic in order to solve problems, or just, in this case, we're not really solving a problem. What we're doing is automating something that otherwise we would do by hand or we would do in some other fashion. So that's programming, used to speed things up more than to solve an existing problem. Okay? Check it out. Let it sit there. Let it steep. You can see I've created one object, but I could have done as many as I want. I can say Joe account, and I can say equals savings 500. And that will create an account for Joe. And then what I'll do is I'll print Joe's account real quick. I'll print Joe account dot get balance. And as we see when we run it, wanna give me a hurry, And as you can see there, I have what I printed out for Joe. So in an instance where I'm running a bank and I have 500 different savings accounts, I can have them all separate, and I can give them deposits, and I can withdraw from them, and I can keep them all separate in that sense. So it's another way of thinking about creating your computer programs. Okay? Let it sit in. Look at this. I will take this code, savings.py, and I will put it in your Unit 5 resource folder so that you can take this, run it, play with it, change things around to learn what it's doing and how it's doing it. Okay, so that's classes. Now, classes aren't going anywhere, because when we come back and do the next slide, we're going to learn about a couple of different features that doing things in an object-oriented way present to us. One is called inheritance, and another is called polymorphism, and they sound serious and complicated, and they are anything but. They're very simple concepts, and once I explain them, you'll have that eureka moment. You'll go, oh, that's not a big deal at all. That's actually pretty smart, and I understand that. So we're going to be using classes all the way through this unit. Truth be told, you're going to be using classes and seeing classes and objects from now until the end of your career, because when you look at professional programs and when you look at the things that you do with stats packages like R and other things like that, they use object orientation. You're going to be calling methods on your data items. Those data items are just objects. And you're going to be saying a dot whatever and my variable dot sort or my variable dot whatever. That's a method being called on object data. That's all that is. So now you're sophisticated enough to start creating your own high-level data types so that you can use them in your own programs. And if we wanted to, we could create a class for a checking account and every month take $5 out of it, because that's what the bank charges us. Even with this savings account, I could add interest every month if I wanted to. And we would have a method that says add interest and do other things like that. So it's just another way to represent the real world with our data and our methods inside of a computer program. All right? That's the bottom line. Not a big deal. You're going to be fine. I agree with that 100%. You are going to be fine. How long and crazy was that beard? That's the kind of thing that you grow like on a bet. If you're making money or you're doing something, well, goodness gracious. How I can't believe I say mine's even getting a little long in the tooth now, but that thing was Rasputin. That thing was nuts. Maybe I was doing it just because I said I was going to grow it out till Christmas. I have no idea. Woo! All right. You got the first video now. So there's going to be two more coming down the pike. One's going to be polymorphism and inheritance, and the other is going to be neat little tips and tricks. We're going to go over a thing called a class variable. We're going to go over deconstructors, overriding string function, a whole bunch of cool stuff. As far as announcements are concerned right now, you're in pretty good shape because we've got the entire month of April, and all you have is Unit 5 and Unit 6, which is a real quick hitter. So the only real announcement thing I'll do today, because I'm going to do two more videos like in the next couple of days, so I'm going to hit you with announcements on the last one. But make sure you and your groups are thinking final project, that you're getting things together. Because right now, what is it, the 3rd? Slowly but surely, that time is going to creep up, and you're going to have your proposal due. And you're going to want to, get a topic with a decent proposal. Most people don't hand in the proposal on the very last day. They'll give it to me a couple days ahead of time so that I can approve it, and then they're happy and they don't have to do extra work. But just in case I don't approve it, or I say, hey, that's a good idea, but why don't you add A, B, and C? Then they can redo their proposal and still get it in on time. So you might want to think along those lines. Don't worry. I'm not a stickler on time. When I give deadlines, they need to be general, As far as projects are concerned, don't think you're handing forum posts in late or assignments. But as far as things like this are concerned, if I get it a day late, it's not a problem. Truth be told, if I get the proposal a day late, it's going to mess you up more than it's going to mess me up, because that's one less day you have to work on the final project. All right? All right, enough said. Video 1 in the mud. You've seen it. Best thing about YouTube videos, you can go back and rewatch it, okay? I am going to put savings.py in your resources, so it will be there for you to tinker around with and use, all right? And I'm going to get out of here for now, but in the next couple of days, I'm going to do the second video and then quickly the third one, and hopefully, I'm hoping that by this weekend, what is today, the 3rd, 4th, 5th, 6th, 7th, by maybe Saturday the 8th, I might have all your videos up. I want to front load all of your resources so you can get going on the assignment. When you see the assignment, you'll know why. I want to get you this assignment as soon as I possibly can, so you have a lot of time to work on it. It's kind of fun, but it's going to make you think. So I want to make sure you have a lot of time with it, but you also have the resources and you're doing things properly. All right? All right, good. Then you get out of here, and I will talk to you again very soon in the next couple of nights. All right, bye.